Now, the next thing to focus on in arithmetic progression is how do you calculate the nth term? Okay, this is something that confuses a lot of students, but it's not as confusing as it sounds. So let's take first example of a very simple arithmetic progression, that is 2, 4, 6, 8, 10, so on and so forth. Okay, obviously this is an arithmetic progression because the common difference is 2 everywhere, right? So this is an arithmetic progression. So a is the first term, so a first term is equal to 2. What is the common difference? D is equal to 2. All right, now let's say I ask you to find first, second, third, fourth, fifth, sixth, seventh, eighth and ninth term of this arithmetic. So this is the first term, second term, third term, fourth term, fifth term, sixth, seventh, eighth, and I want you to find out what is the number that will be ninth in this series of arithmetic progression. That is the question. So I want you to calculate the ninth term. Okay, so how do you do that? And this formula that I'm about to tell you will hold good for all arithmetic progression questions when you want to find the term. Okay, so let's see. Tn is equal to a plus n minus 1 d. This is the formula that you must remember. You'll use this formula up until grade 12. Okay? Now this is the formula for the nth term. What is the n supposed to be here? That is the ninth term. So whichever term that you want to find is the value of n that you're going to put in this formula. You obviously know what is a and you obviously know what is d because the arithmetic progression would always be given. So if it is not given, you cannot use this formula because you'll not know a, you'll not know d. But if the AP is given, and usually it is until and unless the question is too complicated, AP is always given. Okay, so a over here is 2 plus, you want to calculate the ninth term, so you'll put n is equal to 9, then minus 1, and what is the common difference again is 2. Let's calculate this value. What is 9 minus 1? 8. 8 multiplied by 2. 2 plus 16. So that gives you 18. Let's find out if the ninth term in this AP is 18 or not. First, second, third, fourth, fifth. Sixth term is 12. Okay. Seventh term is 14. Eighth term is 16. Ninth term is 18. And this formula stands good for all sums of arithmetic progression. So whenever you want to find any random term, and you should know which term, if you 10th, 11th, 12th, so that way. So if you want to find any random term, this is the formula that you use. Okay, practice using this formula. Practice a lot of questions by simply just using this formula because there is a tendency amongst students to get confused. Should I write n minus 1 is equal to 9th or should I write n is equal to 9? So it's always n is equal to 9. Minus 1 stays regardless of whatever. Okay? I'm sure you've understood this concept. Let us do some examples and then we will move to the exercise. All right. It's important. It's important. Let's see if we can change. Let's go for orange. Right. Okay. So this is the nth term here. Okay. This is the formula that we guys were talking about. A plus n minus 1 d. First term is a. Common difference is d. All right. Chalo, fine. Let's look at the examples first and then we move ahead. We'll also work the examples because, like I said, simply just reading sums won't help. Now the question over here reads, find the 10th term of AP 2712. 2712. So the question itself mentions that this is an AP. So you simply just write A is equal to 2. What is the common difference? 7 minus 2, that is 5. So you know A, you know D, and you have to find the 10th term. So T10 is equal to A plus 10 minus 1 D. Simple. Now in place of A, we put 2. In place of D, we put 5. So 2 plus 10 minus 1 is 9. 9 multiplied by D is 5. 2 plus 9 5 is 45. 45 plus 2 is 47. Let's see the answer matches. Yes. So the 10th term in this series is 47. Let's see. Let's go to example number 4. The reason why I'm doing examples is it really helps you. It really, initiates that concept inside your head. Which term of the AP? Now this is the reverse one. Okay, you've been given AP, that is 21, 18, 15, so on and so forth. Which term of the AP is this? That is something that you must find. So we only have formula Tn is equal to A plus n minus 1 D. Now the twist in this question is you've been given the value of Tn. We don't know the value of n. So which term is minus 81? We are going to find out by putting it in the form of an equation. Okay, so it's given over here. Minus 81 is equal to, what is A? 21 plus n minus 1. What is the common difference? Let's see. 18 minus 21 is minus 3. 15 minus 18 is again minus 3. So this is minus 3. All right. Now we need to solve this. First of all, minus 81 is equal to 21. Okay, let's open this bracket. Plus minus 3 and minus 1. Okay, so all we can do is 21 minus 3 and minus 1. Minus 81 is equal to 21 minus 3n plus 3. All right, I think 3n comes this side. 3n is equal to 21 plus 3 is 24. 24 plus 81. I hope this is right. 3n is equal to 5105. So n is equal to 105 divided by 3. 3 3s are 9. 3 5s are 15. So I think 35th term. Is this correct? Yes. So 35th term of this arithmetic progression is 81. You see, in example number 3, we were asked what is the 10th term. Okay, we needed the value, we needed that number which is at the 10th position in the arithmetic progression. In example number 4, it was reversed. We were given a number, okay, and we need to find which exact position does that number fall in that arithmetic progression. So like the 3rd term, 5th term, 15th term. So the number was given, we needed to find the exact position in example number 4. That is what we did. So this is the 35th term. So what did we do? We found the value of n. So you can also use this formula in this manner. Okay, it's still not done. Also, is any term 0? I'm going to erase this. They're asking, in this arithmetic progression, is there any term that is 0? Again, we'll use that same formula. Tn is equal to A plus n minus 1 D. We don't know which term. So we'll see 0, let's say on which exact position in this arithmetic progression does 0 fall. So 0 is equal to A. What is A? Is given 21 plus n minus 1, and D was again minus 3. You have to be very careful with these signs. Okay, you have a plus over here, you have a negative over here. So always try to unify two different signs. That should be your first priority. Let's see for what value of n do we get this as 0. Okay, 0 is equal to 21 minus 3 n minus 1. 0 is equal to 21 minus 3n plus 3. Okay, 3n comes over this side. 3n is equal to 24. N is equal to 8. So 8th term of this arithmetic progression is 0. All right, this is how you do. Let's go to example number 5. So if you think the speed is too much, you can pause the video, work out the solution for yourself, and again resume. Okay, let's go to example number 5. Determine the AP whose third term is 5. Okay, we have been given third term is 5 and seventh term is 9. So we only have one formula, that is Tn is equal to a plus n minus 1 d. Now the rule of thumb in mathematics is the number of equations that you need to find should be equal to the number of unknown variables. So if there are two variables, two unknown quantities, you need two equations. So what are the two unknowns over here? A and D. Let's see. Okay. So how do I write the third term? So A plus 3 minus 1 is equal to 5. This is the third term. Okay. So that gives me A plus 2D is equal to 5. So this is going to be my first equation. Again, what is the seventh term? A plus 7 minus 1D is equal to seventh term is 9. All this is given in question. I'm not making this up. Okay. So A plus 7 minus 1, that is 6D is equal to 9. This is your second equations. Now the two unknowns that you have is A and D. So two unknowns, you need two equations. We have two equations. Let me just write down A plus 2D is equal to 5. Now plus becomes minus, plus is minus, AA cut. 6 minus 2, 4D is equal to 9 minus 5, 4. So D is equal to 1. Now I calculated the value of D. I get is 1. Now let's put the value of D is equal to 1 in this equation. A plus 2D is equal to 5. A plus 2 into 1 is equal to 5. So A plus 2 is equal to 5. So A is equal to 3. So now you have A is equal to 3, D is equal to 1. So all you need to do is find the AP. So 3 plus 1 4 plus 1 5 plus 1 6. So this is the AP. I hope you understood this question. So whenever you come across such questions, you try to frame two equations if there are two unknowns. So now the number of unknowns should be equal to the number of equations. You cannot have three unknowns and two equations, then you'll not be able to find the value. All right. Is there any other example or no? There are examples. Where is the exercise? All right, we'll try to solve the examples here. Example number 6. Check whether 301 is a term in the list of numbers. Okay. Now this is the arithmetic progression that is given. So what do you do? First find common difference. 11 minus 5, 6. 17 minus 11, 6. 23 minus 17, 6. So clearly the common difference is 6. A is 5. Now we need to find an n. Okay. In this series of numbers, on what exact position does the number 301 show up? Or whether does it show up or not? That is the question. So we only have one formula. Tn is equal to A plus n minus 1 D. So what do we do? Here it's already given. 301 is equal to 5 plus n minus 1 into D is 6. So clearly the value of n is not a number, not a proper number. It's a fraction. So clearly 301 is not a term in this arithmetic progression. Chalo. This you might find this very tricky, but it's not. Okay, let's look at the question. How many two-digit numbers are divisible by 3? So first we write two-digit numbers over here. 12, 15, 18. So the common difference will obviously be 3. The first term is 12. Okay, let's Tn is equal to A plus n minus 1 D. Now the last number is 99. So what is the position of that number? Which number is that? So to find that, I'll put 99 is equal to A plus n minus 1, and D is again 3. So I'll write 99 is equal to 12 plus 3n minus 3. Okay, 12 minus 3 is again 9. Okay, 99 minus 9 is equal to 3n. 3n is equal to 90, n is equal to 30. So total 30 numbers. There are 32 digit numbers that are divisible by 3. Right? Okay, fine. In the next video, we are going to focus on the exercise of the same chapter, exercise number 2, that is exercise 5.2.